Okay, this video will cover vectors and algebraic approach. So there are two concepts that you need to know to find vectors, length, and direction. So you have to know that the magnitude of v, what looks like absolute values, is the square root of a squared plus b squared. And then to find its direction, we're going to do tangent theta equals y over x. And that'll be coming in the next example. So let's go ahead and write that down, though. So tan theta, so in this case, would equal to b over a. So theta is going to be tangent inverse of b over a. And it will be an angle whose initial side is the x-axis, positive x-axis. Okay, draw the vector 3, -4 in standard position and find its magnitude. Now remember, magnitude here just means length. We use the distance formula to find that. So your vector starts from 0, 0, and you go 3, just like you're plotting the point, 3, -4, and you draw an arrow, and that represents a vector. So the magnitude of our vector v is the square root of 3 squared plus -4 squared. Well, 9 plus 16 is 25. Square root of 25 is 5. All right. If u is equal to 5, -3, and v is equal to -6, 4, find the following. So to add your vectors algebraically, you just add your first components together and your second components together. Okay, and so it will be a vector answer, so it will look like this. Your answer is going to be 5 plus -6, comma, -3 plus 4. That's -1, 1. Okay, now 4u minus 5v, I go ahead and I would solve it like this. 4u plus -5v. It's just a little easier on the mathematics. So 4 times u, so that's going to be 20, -12, plus, and then let's multiply by -5. -5 times -6 is 30, -20. So if you add the terms, 20 plus 30 is 50, -12 plus -20 is -32. Okay, write the vector 3, 4 in terms of the unit vectors I and j. Graph the vector and find magnitude and direction. Okay, so your unit vectors I and j. I is in the x direction, and j is in the y direction. So v would equal to 3i plus 4j. So again, notice, almost like an ordered pair, but it's a vector. The x comes first and then the y. So the I first number, the 3, is in the I direction. The second number is in the j direction. Again, if we draw the picture, this is what we're talking about. This would be 3, 4. So the magnitude of v is equal to the square root of 3 squared plus 4 squared. Magnitude of v is equal to the square root of 25. Magnitude of v is 5, but the direction is going to be different because notice this time the vector went upwards. So we know theta is equal to tangent inverse of 4 over 3. So if I do tangent inverse of 4/3, we get 53.1. So theta is approximately 53 degrees. So what that means is this angle here from the x-axis is 53 degrees. Okay, if u is equal to 5i minus 3j, and v is equal to 6i, -6i plus 4j, find u plus v. So again, you're going to add your components. So u plus v is equal to 5 plus -6, -1. -3 plus 4 is 1. Okay, so since those are in I and j, we could write it this way. But notice our original problem is in terms of I and j. So your answer that you want is -i plus j. So u plus v is equal to -i plus j. Okay, same thing. 4 times u, so that'd be 20I minus 12j. Then negative 5 times 6 plus 30I minus 20j. And kind of like algebra, you can think of adding like terms. So it's 50I minus 32j. Danny is 5 years old and weighs 42 pounds. He is sitting on a swing when his sister Stacy pulls the swing backwards, horizontally through the angle of 30 degrees, and then stops. Find the tension in the ropes of the swing and the magnitude of the force exerted by Stacy. Okay. So what's going to happen is we're going to say, here's our swing here, and she's going to pull it back 30 degrees. And so what we have is we have her force, which is H. We have the weight of Danny, which is down. And we have the tension in the spring. Not in the spring, in the swing. Okay, so what we know, if we pull this out into a coordinate system, is we'd have a horizontal force in this direction. We would have tension in this direction. And because this angle here would be 30, this angle with the x-axis is going to be 60 degrees. And then you have the weight down. So the easiest way to do this is to look at it in terms of I and j. So in the I direction, the H, vector H, is in the I direction. In the j direction, we have the weight, which is down. And down is negative. Okay? Then notice your tension. So in the x direction, you would have T cosine of 60. And it's going to be negative because it's to the left. And in the y direction, because it's up, it's positive T sine of 60. So if we add those terms, we're going to get what the forces would be. But because when we pull it back and pause it, it has to add up to 0. So we would have these equations. H minus T cosine of 60 equals 0. And negative W plus T sine of 60 equals 0. So we're going to find the tension first, and then plug that into the left-hand side. So T sine of 60 is equal to W. So T is equal to W, which it says it's 42 divided by sine of 60. And that is 48 pounds. So T is equal to 48 pounds. Then here, H is equal to 48 pounds times cosine of 60. If we solve for the H. So H is equal to 48 cosine of 60, which is 24 pounds.